So next up, we're actually going to talk about a subject that Chairman Perry did mention, produced water. We have Dr. Venki Uddameri here from Texas Tech. He is a professor of civil, environmental, and construction engineering, the director of the Water Resource Center, and co-director of the newly formed Texas Produced Water Consortium. Welcome.
Thank you so much. Thank you for the invitation to come speak here. I had actually said I would speak if I were to go before Senator Perry, because I knew following Senator Perry would be a hard thing to do, but things didn't quite turn out the way it should be. But let's hope an engineer can get this to work. Guess not. Okay, so that reminds me of how many engineers does it take to change? Oh, we lost it completely. So what I'm going to do today is talk about the Texas Produced Water Consortium, which is an offspring of Senate Bill 601 that Senator Perry mentioned. I'm going to talk about give you a broad overview of produced water, a waste or a resource, that's the question. And then some of the challenges and opportunities in reusing produced water, particularly with a focus on non-oil and gas applications. So, and I think hopefully I'll have enough time for questions as we move forward. Okay, looks like, so the Texas Produced Water Consortium, oops. Okay, I just want to point to the email there, txpwc@ttu.edu. That is our address. All the co-directors and others involved in the consortium have access to that email. So if you have any questions, that would be the best place to get in touch with us. So we all know that the water demands in Texas are growing. Much of the old water is already spoken for or is being dwindled or depleting at a very rapid rate, and water availability is becoming less reliable, climate change, changes in climate and such. So the question is, how do we augment this disconnect between the supply and demand? How do we overcome that supply and demand? So clearly there is the conservation side of things. Certainly we need to conserve as much as we can, but at the same time, we also have to be looking for augmenting our supplies with new sources. And are there new sources? If so, can we put those new sources to maximal use? So it turns out produced water, or the water that's produced as part of oil and gas operations, can be a substantial new source of water, at least locally where we have active shale plays. So you can see Eagle Ford in South Texas, the Permian Basin up in West Texas, and you will see that there are other basins as well that can produce oil and gas, and as a result produce produced water. So the Texas Produced Water Consortium was created by Senate Bill 601 during the 2021 legislative session. The consortium seeks to study the economics of beneficial uses of oil and gas waste and technology needed for those issues. So Senator Perry's mandate was very clear. Can we treat this water? Can we treat it to drinking water standards? Because if we can get it to drinking water standards, we can pretty much get it to any other standards of other uses, for other uses. And if there is technology, is there a way to do it cost effectively? So that's our first agenda, or the first charge, is to look at the economics of beneficial uses of oil and gas waste, particularly with an emphasis of using this water in non-oil and gas applications. And so we are supposed to write a report that'll be due in September in a year, in September 2022. And after October 1st, use that document as a basis for planning research and investigation goals that are directed by the members of the consortium. And then, of course, Senator Perry is very clear. He says, if you come out and tell us that, no, we can't treat this water, it is too expensive, it's not possible to do it at scale, then he really wants to put this produced water thing to rest. So the early part of the research is to really look and see, can we use this produced water economically? If so, how, where, why, and when? And then the next step would be to look at research to say what can be done to improve the beneficial use of produced water. So no later than September 21st, September 22, in 1 year from now, we write a report that looks at suggested changes to beneficial uses of oil and gas, or waste or produced water, and guidance for establishing, permitting, and testing standards of produced water. Produced water tends to be fairly heterogeneous. We call it produced water, but just like any other water, the chemistry of the produced water can vary quite a bit, not only across different shale plays, but also within shale plays as well. So I'm going to show you some examples of that. Economically feasible pilot project for state participation in a facility defined and designed and operated to recycle fluid oil, and an economic model. So the focus is, can we build something at scale to treat this produced water, and what are the economics behind this? So is there engineering, is there economics that will support the use of produced water? So the way the consortium is structured, the lead university is Texas Tech. And then we have a stakeholder advisory council that comprises of various water interests related to produced water, oil and gas, agriculture, and you can see that groundwater districts interact with all of these stakeholders. So as a result, groundwater districts are also a big component or big part of our stakeholders. We are guided by a government agency advisory council comprising of participants from Texas Railroad Commission, Energy Conservation Office, TCEQ, Texas Water Development Board, Texas Economic Development and Tourism Department and such, Texas Department of Ag. So this advisory board will advise us on things like what will be the membership fee, how do we bring people, what are the different stakeholders who we should be bringing in, things like that. So, and then, of course, the consortium is open to consortium members who participate in consortium activities, which initially includes planning, but eventually will move towards research and outreach activities. So the leadership, we have 3 co-directors. I'm one of the co-directors. I lead the Water Resources Center at Texas Tech. Dr. Marshall Watson, he's a petroleum engineer, so he brings in perspectives from the petroleum engineering side, and then Dr. Eric Bernard is from the Kastner of the College of Agricultural and Natural Resources, and he brings in the agricultural perspective. So we have 3 co-directors. We have an executive director whose search is ongoing. We plan to fill it within the next 30 days or so. We've interviewed a few, so we're going through that process. And then we have a technical and economic steering committee. Internally, right now, it consists of Dr. Danny Reibel, who is the Donovan Maddox Chair in the College of Engineering, Brad Ewing, who chairs the Free Enterprise Institute at the College of Business, and Dr. Christy Bratcher, who is the Associate Dean for Research at College of Agriculture. Of course, this is going to increase and expand in scope as we bring in other people from other universities and such. So we certainly want you to participate, because the consortium seeks to get input from a wide range of stakeholders. We are working out a membership structure that works for the highest levels of participation. We are required by statute to work with our government advisory board to create that membership structure. So we are in the process of doing that. And if you were interested in the consortium, if you're interested in keeping track of what we are up to. We have a website, but the best way to contact us would be, again, txpwc@ttu.edu. That email goes to all of the co-directors and the executive director and everybody else. So somebody will certainly get back to you with the questions that you may have. So why the interest in produced water? Why the interest in produced water? Certainly we know that there is quite a bit of produced water. When we say produced water, we are using it in a very broad sense to mean all water that's produced during oil and gas operations. So petroleum engineers tend to separate this into flowback water and connate water. Flowback water is the water that during hydraulic fracturing operations, you inject that water, and part of the water that gets injected actually flows back. So its chemical composition looks a little different than the connate water or the water that's present in the aquifer or in that formation, oil and gas formation, not an aquifer, but oil and gas formation, subsurface formation that comes out. The general rule of thumb is that there is typically 3 to 10 barrels of water produced for every barrel of oil that's produced. And of course, this wide variation is seen depending on the shale play. A lot of different shale plays have different amounts coming out. So the running joke in the industry is that oil is essentially a byproduct of water because we produce like 3 to 5 times more water than we produce oil, although oil costs a lot more than water. But certainly there is a lot of water that's produced. What happens to the produced water currently? It is typically, some of that produced water is injected back into the same formation, partly to maintain pressures, because if you bring out a lot of fluids, it can cause subsidence, it can cause other pressure-related concerns. So to maintain that, some of that water gets injected back. Some of it is being reused in hydraulic fracking operations, particularly if there is same company trying to do fracking in nearby areas. They tend to exploit or reuse this. This technology has gotten better in the last decade or so because of slick water fracking or advances in slick water fracking that allows people to use high TDS waters. Okay. And of course, still there is a lot of water that remains, and that water gets disposed via deep well injection. There are roughly about 8,000 saltwater disposal wells in Texas. If you drive through West Texas or even South Texas, you will see this saltwater disposal facilities scattered all around. We did some work a few years ago and found that the average distance between a hydraulic fracking well and a saltwater disposal well in West Texas in Permian Basin was roughly about 3 miles, less than 3 miles, but on average it was about 3 miles. So not very far and very cheap to dispose this, typically less than $1 a barrel or much less than $1 a barrel. So that is what we want to see. If it's not put out in a deep well and taken out of the hydrologic cycle, but can we use this water for other purposes so that it still remains in the hydrologic cycle and put to beneficial use. Water quality certainly is a limiting factor. Typical produced water contains organics, inorganics. It contains naturally occurring pollutants or constituents, and then it also contains anthropogenic constituents. Organic compounds, naturally occurring hydrocarbons, because it's coming out of an oil and gas reservoir. It will have some additives, it will have some biocides. Biocides are used particularly when the water is reused. They tend to avoid the microbial activity downstream. You've got very high thermophilic and salinity, high salinity bacteria that are adapted to high salinity. So biocides, fairly strong biocides are added for that. And that's one of the critical factors. We need to remove this if we want to make this drinking water standards. And then typically you will see about 2 to 20 micrograms per liter of BTEX compounds. Those can be treated. It's not too difficult to treat organics. But inorganics really are the problem because the water there has been sitting for a very long time, so it has interacted with the mineral matrix around it. It's got major ions, trace constituents, naturally occurring organic radioactive minerals, you name it. There's quite a bit of organic compounds in there, all of which typically exceed drinking water standards. So the TDS levels, I'm showing the TDS in Permian Basin in the lower box plot there. It varies anywhere from about 5,000 milligrams per liter, which is not bad. It's almost like brackish water in many formations, to about 300,000 milligrams per liter. So a very wide variability in TDS. And that red line there is the 50,000 TDS line. You can see that about 75% of the water samples that we had exceeded that 50,000. 50,000 is a rough cutoff whether you can do desalination. Like the typical RO-based desalination cutoff is about 50,000. There are ways in which you can dilute that water and run it through ROs, but it just adds to the technology, adds to the cost. So really the inorganics are a bigger challenge in dealing with this produced water. This again shows you some water quality characteristics of major ions. Again, you can see that everything is way above the limits. So direct use of produced water in anything other than oil and gas operations requires some sort of treatment, which means there is some cost involved in using this water. Of course, the water tends to be very heterogeneous. So there are certainly spots where this technology will not be feasible right off the bat, but there are certainly some sweet spots. I mean, you have a 5,000 TDS water, bringing that to like 1,000 TDS is not all that expensive. But if you have 100,000 TDS water, trying to bring that to 1,000 TDS certainly adds the costs scale up exponentially. So that's an issue. In addition to the water quality, there are other challenges as well. Water is produced in a decentralized manner, so the areas where water is needed tends to be more centralized, the urban centers, if you may. The second issue with that demand disconnect is also the fact that if you want to use this for municipal uses, you have to have a steady supply of water, whereas the fracking water tends to exhibit quite a bit of variability, or the oil and gas production water tends to exhibit quite a bit of variability, temporal variability, because of the price of gas and how much gets produced. Water is a heavy fluid, produced water in general. The density is more than that of the salt water, of seawater. So typically about 1.04, 1.05 grams per meter cube, even grams per centimeter cube. So conveyance and transportation is also, if you want to do centralized conveyance, like put pipe networks, it's going to be expensive to do that. Most of the water is now sent via trucking. I know some cities are trying to reuse this water in industrial applications. That tends to be more on a trucking basis, but in the long-term sustainability, trucking water from one location to another is not very viable, especially if you want to use it for non-oil and gas uses. There are regulatory issues, the big question of who owns the produced water, what are the risk and liability issues, like when the water gets transferred from one entity to another entity, are they assuming these risks, what are the risks, who gets to pay for it? All those have to be kind of worked out if we were to make this water usable. So there are some technical challenges, but also some regulatory challenges that need to be worked for. So I'm going to end with a few opportunities and future research directions that we're looking at. Again, the key question is, can we start with water that's on the left, real dark, muddy water, and then move it all the way across to make it potable? Okay, so one of the key issues that EPA and others struggle when it comes to using produced water for drinking water standards is, what are the constituents in this? There are many, many, many constituents. So the question is, can we characterize what's in that water? What is that unassumed risk that not only are we looking at the priority pollutants that have to be regulated by mandate, but what other things are there that could potentially cause risks that we are not capturing? So that is an issue, particularly the use of biocides in this water exacerbates that risk. There's a lot of controversy and debate on what type of health risk do they pose. So that's one of the challenges. So quantifying health risks, clearly a big area of research that needs to be done. Even if you find ways to economically treat water, then the risk associated with that water will be the limiting step. Okay? There is quite a bit of an optimism in the industry that it is possible to treat it to drinking water standards. We just had a small industry stakeholder group meeting in Lubbock a week ago, and overwhelmingly people were saying, yes, the technology exists, it's just way too expensive. Like it costs about $3 a barrel or so to do that. There are places like in Marcellus Shale up in Pennsylvania where this is done more routinely than it is being done in Texas, but they do feel that the technology exists, but it's a question of cost. It costs maybe around $3 a barrel as opposed to saltwater disposal, which is a lot less than less than $1 a barrel. So the other is, how do we make water treatment economical? One option is to mine for things other than water. Rare earth elements, REE, is a big, there is quite a bit of rare earth elements, particularly in West Texas produced water, you see quite a bit of lithium. Lithium can be, there is a worldwide demand for lithium because of batteries, because of cars. With Tesla plant coming in, the interest for lithium is high. So this could be a potential source, not just for water, but for lithium as well. So there are ways in which we can extract things out of the water and make it economical that way. Of course, we are producing more produced water than we can use, which means that it has to be stored. Where do we store it? So that's another big area of interest. Can we put it in aquifers? If so, what are some of the challenges of doing ASR with these types of water? Clearly, we are putting water that is we are injecting a heavier density water into a lighter density formation, which is kind of opposite to what happens in most ASR applications. So that can create some unstable fronts, cause fingering, cause preferential flows, things like that. The connectivity of the deeper brackish aquifers to shallower freshwater aquifers is very poorly studied. So if we start putting it into deeper aquifers, will that water upcone itself into the fresher water formation? And if so, what impacts will it do to the freshwater resource is another challenge. And deep formations tend to be a lot tighter. So if we are looking at Ogallala and Dockham, you will see the drawdown of Ogallala tends to be much, much smaller for a given pumping than for Dockham, which is the aquifer that underlies Ogallala over much of West Texas. And the same thing happens when you inject too. The recovery is going to be much spread out as opposed to being localized in one location. That has issues of who owns the water, what happens if the water goes into neighboring people, what is the risk to them, a whole host of issues that need to be resolved before ASR can be pursued. Again, the industry again wants to see some flexible permitting process, with a focus on reduction of freshwater footprint, promote reuse outside oil and gas industry. Again, clarity on ownership of produced water, standardization of protocols, because produced water is not a single entity. It's made up of very different chemical compositions. So what can work in some place may not work in other place. So things like produced water trading, if you talk to economists, they're like, can we inject produced water here, substitute it for fresh water somewhere else? That would be a trading type protocol. So things that can happen. New Mexico, we were talking to the New Mexico Produced Water Consortium. They have a very strong interest in putting fresh water in hypersaline environments. This happens in Texas. The Brownsville puts its produced water concentrate or from its desal plant, a brackish water concentrate into Bahia Grande. But sections of Pecos River tend to be saltier than what treated produced water are. Can we inject in those? So 601, the focus is on produced water, looking at it as a new source. Can we start using produced water for non-oil and gas uses, if possible, for municipal uses, is what the charge is. It's certainly a fertile ground for collaboration with groundwater districts and with others, because eventually we are trying to protect groundwater by trying to substitute produced water in some ways. So I'll stop with that, and hopefully we have time for a couple of questions. I'll be happy to answer any questions.
And we'll look to the audience first. I did get some on our app as well. So if anyone wants to raise their hand, otherwise I'll read the ones I've got here. Okay, great. So one came in asking, is this enough time to get all this work done with the Produced Water Consortium and the legislation?
Right. Yeah, that is high on our minds, And as I said, the first step is the feasibility part. We want to look at what's existing, what are the existing technologies, what are some of the challenges, place it in front of the legislature, and say these are some of the promising areas where we think we have to work if we want to make this a reality. So our first goal is to kind of do that assessment, and the better job we do with that assessment, then potentially we'll have support from the industry and the government to move things forward. So if I were to do all this in 1 year, the answer is no. But the idea is, can we get a very broad swath of what's happening with produced water, get people's concern in? So that's one thing why we want to be very transparent, very open. No ideas are bad ideas at this point. We want to collect as much as we can, brainstorm about them, and then provide a technology evaluation.
Great. And then another one came in asking, and you actually mentioned New Mexico on your slides.
Right.
Do other states provide a template maybe for how produced water can be beneficially used?
No. It tends to be a little state-specific. For example, in Pennsylvania, with Marcellus Shale, there was a big push to treat that water and use it for either non-potable or drinking water uses. So the state almost said municipalities have to take this water, treat it, because they don't have saltwater disposal wells like we do. The New Mexico Produced Water Consortium started a few years ago. Their mandate was slightly different. They are looking at reuse just like us, but they had a little bit more of a research focus than ours. Ours is more a two-step process where we are first doing a broad swath assessment of what the technologies are before we go and delve into the research aspects. So right now there is really no template that we can follow. And even within the state of Texas, the shale plays are very different. So a template in Permian Basin may not necessarily translate fully to something in Eagle Ford, partly because we don't have as many surface water sources as Eagle Ford Shale does, and those become important. So the idea is that we have to kind of start on our own, see what people have done, why they have done certain things, but adapt it to Texas.
And then another one came in about the, is there a hand?
Yeah.
Has it ever been blended with purple water?
Yes.
Can you repeat the question?
Yeah, the question is, has this been blended with purple water, right? Or any other form of water, deeper aquifer waters or wastewater or something that, answer is yes. People do that in the oil and gas industry. They take water, brackish water, and then mix it with produced water to reduce the concentrations. Doing it for ag is extremely difficult because of the high salt concentrations. So there are people looking at creating salt-tolerant cotton varieties and things like that. We can go up to like 4,000 or 5,000 TDS now with cotton, particularly if it's for just fabric use and not for cotton seed oil. But still, bringing something from 50,000 to 5,000 is a challenge, especially for a crop like cotton that's not very economical.
Make sure I don't talk over anyone
Right.
before I got one here.
The initial funding source is from the Texas legislature to write that interim report that they want. After that, they want it to be more a membership format with research being funded by interested parties. We cannot take money from any other state agency, but the idea is to help get industry partners or do some public-private partnerships to do the research part of it. Absolutely. It's a good question. The question was, how do we become consortium members and what role do the consortium members play? We are required by statute to work with our governmental advisory group to form a fee structure that allows various people, various stakeholders to come in and participate. So we are in the process of setting that up. So again, your participation, we are forming some subcommittees looking at different issues, water quantity issues, quality issues, economic issues, conjunctive use issues. So you can participate in those committees. We'll make that open, and our goal is to have it open so that you can participate in as many committees as you want. You can share data with us that you have that would be useful. You can participate with us in terms of like finding sites or collaborations where we can do some of this field testing or field projects or dovetail with another industry that's trying to do something, try to learn from that. So as I said, there are various modes in which you can participate. Or you can certainly provide us with insights related to your constituents, how they're using groundwater in your district, or what do they think of produced water. Those are also important in terms of like the regulatory aspects surrounding it. So if you're willing to participate, we'll find something that's of interest to you. Because this is such a vast problem. We know that one person cannot solve it. The 3 co-directors cannot solve this. So, Senator Perry loves if we get more people to talk to us and get their perspectives included in it. So we are all for that. Again, participation can be, if you want to come in as a district and say, this is my district position, that's fine. If you want to come in as an individual and say, I'm a general manager, I have a lot of this data, or I have a lot of this information or insights that I can share, that'll work too. Typically, I think memberships would be more at a district level so that it allows multiple people to participate as opposed to an individual participating. But we're working that out. Well, we should have the details. If you can get us on our mailing list, if you just shoot us an email at txpwc@ttu.edu, we can certainly keep you updated as we move through this process.
And I think we have time for one more question right here.
I'm sorry? Oh, that's a good question. So the question is, besides USGS, is there a produced water database? The Railroad Commission has some data. They have made it freely available recently. It's just not very, you'll have to go and look for multiple places to put that database together, but certainly that data exists. There are some data that are with local industries, which of course is behind their paywall, or it's for their own internal use. But we are trying to work with those entities to see if they can make some of that data available, at least, or publicly available, without giving out the specifics, like maybe down to a census tract level or something, as opposed to exact lat longs, which they may not want to give. So we are kind of looking at that process as well.
Wonderful. Thank you so much for that.
Well, thank you again. Thank you for having me come here and talk about the Produced Water Consortium. So again, if there are any questions, please feel free to email us. We would love your participation.